Alright, let's cover Unit 4 of the study guide, which is gas laws. Let's start off with number 1. Convert 27.6 degrees Celsius to Kelvin. Our equation is this: C plus 273 is Kelvin. This is not given on your study guide. You have to memorize this. C plus 273 equals Kelvin. So C here is 27.6 plus 273 will give you Kelvin. When you type this in your calculator, you will get 300.6 Kelvin as your final answer. Number 2. A balloon is filled with a sample of helium gas. If the temperature is decreased, what do we know if true? What do we know if regarding the what do we know of the pressure, volume, and number of helium molecules? The question is worded terribly. So if temperature goes down, then for pressure will also go down according to Gay-Lussac's law. Gay-Lussac, which states that the temperature and pressure are directly related. Next, volume. Volume will also go down, horrible downwards arrow, down, according to Charles' law. Charles' law, because it also states that volume and temperature are directly related. Cannot spell today. Directly related. All right. Finally, for number of particles will stay the same. So, number of particles stays the same, stays constant. Because if you logically think about it, just because the temperature decreases, it does not change the number of particles. So that means that if our temperature decreases, it has no effect on the number of particles. And therefore, we have all of our information now. Pressure goes down, volume goes down, and number of particles stays constant. Let's try number 4. It should be number 3, but we'll call it number 4. A gas has a volume of 1.75 liters at negative 23 degrees Celsius and 150 kilopascals, kPa. At what temperature will the gas occupy 1.3 liters at 210 kPa? So, we have to figure out all of our variables. We have volume, temperature, and pressure. We also have volume, pressure, and we're looking for temperature. So we're involving 3 variables: volume, pressure, and temperature. The only law that involves these 3 and these 3 alone is going to be the combined gas law. Combined gas law. And this is given. The combined gas law says the P1 V1, so pressure and volume, and temperature of the first gas will also occupy the second gas, or second scenario, P2, pressure 2, volume 2, and temperature 2. All right, we established our variables. So we have volume 1 here. Temperature, we have to convert temperature to kelvins. So we have temperature 1 and pressure 1. And we're looking for temperature 2, and we know volume 2, and we know pressure 2. All right, so for temperature, we always want to convert to Kelvin. So for combined gas laws, as long as the units excluding temperature are the same on one side as the other, so liters, kPa, kPa, we can just go ahead and keep it that way. But for temperature, we have to convert this to Kelvin, which means that we have to use our equation from the start. C plus 273 equals Kelvin, which gives us in our calculator negative 23 plus 273 will give you Kelvin. When you do this, when you actually do this, it'll give you 250 kelvins. So keep that in your mind. So we'll just keep it there. So we have P1, pressure 1 right here, 150. Volume 1 we have right here, 1.75 over temperature 1, which is 250 K, equals we have pressure 1, which is 210, or sorry, pressure 2, which is 210, volume 2, which is 1.3, and we have temperature 2, which we don't know. All right. When you algebraically solve this, we're going to get right here, we're going to get everything but the T2. You solve this, we're going to get on this side 1.05 equals, and then multiplying these two, we get 273 over T2. So that means that we take 1.5 and or 273 divided by 1.5, and we get T2. So 273 divided by 1.05 will give you 260. Remember the units in Kelvin for temperature 2. So that is your final answer. Let's try number 5. If a 5280 liter cylinder is filled with hydrogen gas to a pressure of 106.4 kPa at 25 degrees Celsius, what is the mass of hydrogen gas present? And it gives us the molar mass. Let's convert Celsius to Kelvin first, because for every gas law equation, we have to have this in Kelvin. 25, so the equation is C plus C as in Celsius plus 273 is Kelvin, which gives us 25 plus 273 is Kelvin, which means that when you type this in your calculator or do this in your head, you're going to get 298 Kelvin. Knowing this, let's determine our variables. We have volume, we have pressure, and we have temperature. And it gives us the question that we need the mass. That means that we're going to use our ideal gas law. Ideal gas law. And this is also given. Excuse me. The ideal gas law is PV equals nRT, N being the number of moles, and R being the constant for gas laws. So, pressure, we established it was 106.4 kPa. Volume, 5,280, equals number of N, which is moles. We have the R value, which is on the front of your study guide, which is 8.31, the gas law constant, and T, temperature, which is 298 Kelvin. So something to note here is that for the units, we have to remember that pressure has to be in kPa, always. Volume has to be in liters, always. N has to be in moles, always. R has to be in the unit that's specified in the study guide. It's quite long, but if I were to look, say the unit, it would be kPa times liters over Kelvin, K times mole. And then temperature, of course, has to be in kelvins no matter what. That is why I didn't convert anything here, except for the temperature in kelvins, because they are all set for use in the ideal gas law. So upon doing this equation, on the left-hand side, we are going to get 561,792 equals, and then we have these two right here, which is going to give us 2,476.38 times N. Dividing by 2,476.3 on both sides, we are going to get our N value of 226.81 moles, or sorry, 86 moles. But with this, we're looking to find the mass. Mass is always in grams, so we have to convert using the molar mass. So mass, we start with the amount that we found, the moles, 226.86 moles of H2. For every 1 mole of H2, we have our molar mass, 2.02 grams of H2. Therefore, our units for moles of H2 cancel, and we're left with grams of H2 giving us the mass. All we got to do is 226.86 multiplied by 2.02, and since there's nothing on the bottom, we don't have to divide by anything. Upon doing this, we are going to get 458.257, which I'm going to round to 458.26 grams of hydrogen gas. That is our final answer. All right, number 6. Air is made up of mostly oxygen, nitrogen, and argon. The pressure due to oxygen is 0.66 atmospheres, the pressure due to nitrogen is 0.26 atmospheres, and an unknown pressure of argon is present. If the total pressure is 1.12 atmospheres, what is the partial pressure of argon? So we have three variables. Let's make it simple and say oxygen O2 is going to be X, nitrogen is going to be Y, and argon is going to be Z. So we're going to say that X and Y are given because they are given 0.66 and 0.26. So we got to find the total pressure, and in order to do that, we have to use Dalton's equation or Dalton's law, which states that pressure 1 plus pressure 2 plus pressure 3 and ongoing like that is going to equal to the total pressure of the the total pressure when you add up all the partial pressures. Therefore, we know already that the total pressure is 1.12. That's given. That's going to be equal, or I'll just put it on this side. So we know the pressure, the total pressure is 1.12, and we know that we're looking for the argon, which we're going to set to Z, and that is the next one we know is nitrogen, which is 0.26, and the first one we found was oxygen, 0.66. Adding all those up, you're going to get 9.92, and when you do that, you're going to get 0.92 plus Z, which is argon, is going to be 1.12 total pressure. Subtract 0.92 from both sides. This goes away, and we get minus 0.92, and we're gonna get Z equals 0.2, which is going to be the pressure of argon. Pressure of argon. Therefore, we know that our final answer is going to be 0.2 atmospheres of argon. And that is our final answer. And we are done.